Okay, let's get started. So yesterday, I gave a brief walkthrough about the course contents. What are we going to do, especially in the machine learning module? So we learned about different types of machine learning that we will be covering, like regression, classification, building recommender systems, forecasting, text analytics, etc. So today we will cover the tool part, like what are the tools that we are going to use as part of this course. So when it comes to tools, the first one is the programming language. So we actually start this course with the introduction to Python as a programming language, right? All these tools that we are going to use in this course are open source. And Python is also a open source programming language. And this is the official website for Python, python.org. So if you go here, you can see download Python 3.11. So this is the major version, and this is called the minor version. Right now, we are actually using 3.9, and it doesn't really matter. The minor version, there won't be much significant differences. So you can see here from 3.9 to 3.10 and 3.11, it's some minor bug fixes. More than that, there won't be much of a difference, right? So to be frank, if we have a version that is like 3.7 and above, more or less the same. So we don't have to really worry about the version of it. Whenever you install, you always install the latest version. Let's say now the latest version is 3.11. So you go ahead and install this 3.11. Python is available for all operating systems. I'm using a Windows PC, so this is a Windows 1. It's available for Linux, Mac OS as well. So if we want to use in a Linux, Unix, or Ubuntu machine, then you can pick the appropriate version. If you have a MacBook, then you can use the MacBook version. Okay, but there is a inconvenience here using this approach. Now, what is that inconvenience? Let me tell you. When we install Python from here, what it installs is a base version of the Python. You can call this, let's say, the Python core. But for us to actually leverage the power of Python, we will be using a lot of packages. So we call them as package. You can also call them as modules also, but it's generally packages. That is a common word. There are thousands of packages. How many packages are there? I mean, we don't know. There could be easily 5,000 plus packages. And these packages won't get installed when we install the Python core. So here, when you try to download this, it it won't install the Python core. Sorry, it installs the Python core, but not the packages. As a data scientist, we will need a lot of these packages to be installed for building all these machine learning things, etc., etc. So we at least need, if not all the 5,000 at once, maybe the most popular packages that are used by, let's say, in data science, right? Yesterday, I briefly mentioned for a data scientist, it is these packages: NumPy, Pandas, Matplotlib, Seaborn, and sklearn. For now, let's say these are the most important packages for data scientists. NumPy, which stands for numerical Python; Pandas, which stands for panel data. Panel data means data that is like arranged in the form of rows and columns. So this is typically what we call as panel data. So in data science, we deal with structured data, which is in this form, rows and columns. So to manipulate them, we actually need Pandas. Matplotlib and Seaborn, these two for data analysis, data visualization. And scikit-learn, this is the holy book of ML and Python. So let's say we need to install these packages, but it doesn't mean that if I have to install Matplotlib, I only have to install Matplotlib. Matplotlib may have another 10 dependencies. That means to run Matplotlib, we may need another 10 packages that are dependencies for Matplotlib. So for installing Matplotlib, we may also end up installing the other 10 dependency packages as well. So what are they? How do we identify them? That's the trickiest part. To avoid these, what we have as an alternate is another version of Python. This is also Python, right? Like, I don't know whoever named it. It's a bigger brother of Python called Anaconda, right? And this comes with a lot of these packages pre-installed so that you do not have to worry. So if you go here, let's say you see Anaconda distribution, and here it says download for Windows. If you are using a MacBook, or if you are using any Linux-based operating systems, you can pick your version here. See, if you choose MacBook, it will go to the MacBook ones. If you have a Linux machine, it will have the Linux versions as well. One thing that you have to notice here is, as of now, the Anaconda distribution is using Python 3.9. I said, right? Python 3.9 is the most stable version as of now. So we will be using Python 3.9. But though Python 3.11 is already released, we will mostly prefer to use Python 3.9 itself. And as such, this minor version won't make much of a difference. Maybe once in a 6 months or once in a year, we can update to latest Python version. But every time there is a new version, we don't have to install it. So if we pick this download for Anaconda distribution for Python 9 and install it, it would be a .exe file, and install it. it would install the core Python, like what I have just said, plus a lot of packages that are especially required for data science world. Okay, so Anaconda distribution was mainly built for the data science community. And that is the reason when we use Anaconda distribution, it would bring a lot of packages along with it, especially that we use in the world of data science, right? If you are, let's say, using Python for something else, you are a full stack developer, or you are a web developer, or you are something else, right? Then Anaconda distribution might not have all the packages, all the required packages that are essential for you. You can install them one by one. Okay. Any questions so far? Okay. Once you install this, these are simple steps. You just keep clicking next until the installation is complete. Accept everything on default settings. Don't change anything when you are installing. Just keep pressing yes, or next. Your installation will be completed. Once the installation is completed, please. Good.
I'm sorry. So are these updates, whenever there is a new version, are they updated automatically, or do we update it manually?
It will
Python,
pop up.
Anaconda.
It will pop up like, hey, a new version is available. Do you want to install it?
Okay.
Then you can make a choice whether to install it or not.
Okay. All right. Thank you.
Yeah. So on the UI, it will show, hey, a new version of Anaconda is available. Would you like to install? Then we make a choice whether to install or not.
You were talking about Colab yesterday at Google. So
I will, yeah, I'll come to that. I'll give more details.
Okay. Okay. All right.
Because what advantage we get Colab and what advantage we get when we have something installed on our machine itself, that we will see. So once we install this, then we have something called as Anaconda Navigator. I'm going to show it. Just it's coming up. So this is how the Anaconda Navigator would look like. Okay. Once you complete the installation of Anaconda, then you can just go to search and say Anaconda Navigator. So you can see here, this is the Anaconda Navigator, right? So when you search this and click open, this will come. So on the home page, you see a lot of things like this: data lore, IBM Watson Studio Cloud, Jupyter Lab, Jupyter Notebook, PowerShell, PyCharm Community, IPython Console, Spider, VS Code. Most of these are the IDEs. What is an IDE? So that is development environments. For any programming language, to make the development process easy and manageable, there are a lot of IDEs. So if you are familiar with some other programming language, someone said Java, right? They might be using Visual Code Studio, or they might be familiar with Eclipse, like that. So These are the IDEs that are available, and we can use one of these. And you can see here, there is R also. So these days, the latest version of Anaconda comes with R also integrated into it. That's why I said, right, Anaconda was mainly built for data scientists by data scientists, and that's why all these things that you see here are the things that are typically used by data scientists. Among these are the most popular UIs or IDEs used in the world of data science. So this is first choice, this is second choice, this is third choice, and this is fourth choice. This and this, Jupyter Lab and Jupyter Notebook, more or less same, more or less very similar, with some minute differences. But either we can use Jupyter Lab or we can use Jupyter Notebook. In the data science world, 90% of the people use these two, Jupyter Lab and Jupyter Notebook. The main reason why this one is so popular is in data science community is the convenience and the ease of usage. That's the whole part. If you are coming from some other programming language, you might already be very familiar with using Visual Studio Code. So we can actually use Visual Studio Code as well here. Spider is another one. If people have been working in R for quite some time, R as R programming language, then they might be very familiar with Spider. So we can also use Spider as our development environment. The other set of popular UIs are PyCharm. If somebody is not a data scientist, and if they are using Python for either full stack development or any other type of work, there is a high chance that they might be using PyCharm as their IDE. This is community, PyCharm community, which is called as free version. This is PyCharm Professional, which is the paid version. So if you want to take a paid version, so you can use this. If you want to use the community version, then we can use this. One thing to notice is, for some of these, you have something called as launch button. But for few, it says install, right? So when it says install, that means that component is not installed for you. So for example, let's say when you install Anaconda and come to Anaconda Navigator home page, for VS Code, it might show install rather than launch. So if you want to install it, you can just click on the install button and that would get installed. For now, ignore all of these things over here. We would be using Jupyter Lab or we would be using Jupyter Notebook until we are very comfortable using Python and Python as our programming language. Once we are very good at it, then we can think about either using VS Code or we can use PyCharm, right? For now, Jupyter Lab or Jupyter Notebook is our go-to IDEs. Good. Now I'm going to click the launch button for Jupyter Lab. So when I click launch Jupyter Lab, what it's going to do is it's going to use a web browser. Let's say this is the web browser. And on this web browser, it will create a new tab and we will see. Wait a minute, it's taking time. I have to restart it. See here, somebody asked this question, do I have to update or will it automatically update, right? So when I opened my Anaconda Navigator, it popped up, update application. Hey, there is a new version of Anaconda Navigator available. We strongly recommend you to update. Now, if you want to update, click yes, or you can simply say, no, remind me later. Right now, I'm going to ignore that and focus on this one. So let's click the launch button. It should open a browser. See here, it opened the browser and it created a tab on the browser. And you can see here, localhost 8888 lab tree something something, because I have been using it for quite some time. So when I actually launched this, it showed something. But when you open this for the very first time, this is how it would look like. Now here you have few things like notebook, Python 3. I told just a little while ago that we would be using Python 3. Python 3 is the major version. 3.9, 3.10, 3.11, those are the minor versions. So it doesn't really matter. Earlier days, it was Python 2, and there is a significant difference between Python 2 and Python 3. When industry moved from Python 2 to Python 3, most of the legacy code that was in Python 2 also migrated to Python 3. So right now, the major version that we use is Python 3 itself, right? And there are a few things over here, like we have something called as a console. If we close this, we can click on Python 3. And it created a notebook. This is what we call as notebook. Notebook is our development environment. And this is the same UI even Google Colab is using. What they are using as the UI is nothing but the notebook itself. So it created something untitled .ipynb, which stands for IPython notebook. Okay, so that's why it is, the extension is .ipynb. When we save a Python program, generally we use the extension .py. But when we save a notebook, it will have the extension IPynb. Now, what is the difference between a notebook and a program? That we will see. If I want to rename this, see here, I selected this untitled .ipynb, and here you will see delete, rename, etc., etc. So if you want to rename it, let's say this is my first Python program, then we would just say first.ipy. You can see the name got changed, and this is called shell. In this, we will be writing our programs. So we can add how many cells we want, and we will be writing our programs like this. If we are writing a base that is like the core Python. Let's say I wrote this statement yesterday, a is equal to 10, print a, and click on this button. You can clearly see this part is executed and the output is printed right below that cell. Like generally what we do in a notebook. In a notebook, we can write something and we can add some output to it, like just below that piece of code. You can say, hey, if we run this piece of code, this is the output that is going to come. And we can also add some notes to the code, like, hey, what it is doing, how it would behave, etc. For example, here, I want to write some notes. Then I can say, from this drop-down menu, instead of code, I'm going to pick something called as Markdown. Hey, this is a first Python program. The moment I run that shell, see how it became? When it is in the Markdown form, it was like this. This hash here, generally in Python, hash is a comment. Let's say, if we put a hash at the starting of any line, then it is a comment. But we are actually not writing a comment here. We are actually creating notes. We call it as like the markdown. So when we put this sign hash, then it is going to create, when we execute this step, it would show it in kind of like HTML layout. So that's why it has become like this. This is a very good way of arranging our code, the output, and the notes, comments, everything in one place. Like how you write your notebook, you can do everything on this. That's the reason it was actually named as notebook. The other good part about this notebook is, now if this is automatically saved, so we don't have to explicitly save. So the moment you create a new cell and write some code into it, let's say is equal to 20. Now this is like saving completed. See here, you don't have to explicitly save this. So saving part is like already done. Now if you close this, let's say discard, and you want to reopen this, nothing is lost. Even the executed results along with the comments, everything is intact. Now if I send this to any one of you as an email, let's say I download this file with the extension .ipynb, and you get that file, you bring that file over here. Let's say, sorry, this is like creating a new folder. Let's say I sent you a IPython notebook file. Let me see if there is an IPython notebook file here. No. Okay, let's assume that I sent this piece of code to you, and you upload that file over here. You click open that file, it would look exactly like this. You haven't executed it on your computer, but whatever the execution that I have done, along with the results that I have produced, it will show up. You don't have to execute to see the results, right? Now, isn't it a great thing? Just say, if you want to see what this code is and what output it generates, You don't have to even execute it. You can just read this, like how you read a notebook, and you would get the picture. Notebooks makes it easier for sharing. Like now I create this notebook, I share it, you will get it, right? Now, if I can download this into a Python file, let's say here, go here, export this notebook as, right? Or we can use the download option. We can actually download this like .py also. Then all this output will get deleted. Only the code part will remain. So if only the code part is there, that with an extension of .py, then that's called a Python file. It's a Python program. If it is .ipynb, it's a combination of code, comments, notes, output, a lot of stuff. Okay. Any questions so far? Okay, good. Now, let me come back to the Colab. Okay, before I go to Colab, let me talk about some of the advantages of using your own Jupyter notebook along with Anaconda, etc. Right? Though Colab is free, but since it's provided by Google, and there will be some sort of infrastructure restrictions on Colab. If you have a very good, powerful PC, like for example, these days, a lot of us has very super strong computers in the form of laptop itself. i9 processor with uh, uh, 8 cores. It can run almost like 16 threads, 32 GB RAM, 64 GB RAM, and even a powerful GPU, right? So if you have a very powerful laptop, we can use the infrastructure. You can use the power of your laptop if you have, let's say, Anaconda and other things installed on your machine itself. When we go to deep learning computations are very heavy exercises. Sometimes we write a program and we just click the execution. It takes hours for that program to execute. Yeah, you heard it right. Not even minutes, hours. There were times where some of the programs has actually ran for more than a day. I just run the program, go home, come back next day to office to see if the program is executed or not. The reason is they are computationally so heavy. Now, to make things a little easier, when we go to deep learning, instead of running the code on CPU, we can actually leverage the power of GPU, if at all we have one. If we don't have one, that's okay. We can still run it on CPU. On GPUs, the deep learning code, depending upon how powerful your GPU is, can be anywhere between 10 times to 100 times faster than CPU. So if you run the same code using CPU, let's say it takes 4 hours, you might be able to complete that in 40 minutes, 50 minutes on your GPU, right? If you have an extremely powerful GPU, then you would be able to do it in 15 minutes also. That powerful it is. These days, it's common. People buy powerful laptops, if not for this, at least for gaming. So if someone is into gaming, they're very much aware of GPUs and different types of GPUs, how powerful they are. So if you have one, why not leverage the power of it, right? So we will. And this is available to you all the time. Let's say Colab, due to some problem, if it is down, even Google services can go down at some point in time, right? So if it is down for some reason, then you may not be able to leverage it. But if it is your computer, you can use it like any point in time. So if you have a very good computer with powerful CPU, good amount of RAM, and even GPU, then we will use this. Install Anaconda and use the Anaconda launcher, get Jupyter Lab or Jupyter Notebook. These two look very similar. So I'm going to show Jupyter Notebook also. Just that the UI in Jupyter Lab, you have the browser UI here, but in Jupyter Notebook, the browser UI is here, and then you go and pick one of these from here. That's the only difference. Okay, but apart from that, more or less, the notebook one is going to be very similar. Now let's go to Google Colab. Yesterday, we created this notebook, new notebook. It was not named, so that's the reason it says untitled 0.ipynb. It was created on 3rd March, that is yesterday. Now let me click on this. You can watch Google Colab tutorial. They have a good tutorial. It's so easy to pick, let's say half an hour, and then you have already mastered it. So don't you see a lot of similarities between these two UIs? So here on the left, you have the browser tab. On here, you have the program tab, and here you have some controls. You can see very similar thing, like you have controls over here and here, and here you have the browser tab. So if you want to, let's say, upload a file from your computer, somebody sent you IPython notebook, and you want to open that IPython notebook and run it on Google Colab, yeah, you can do that, right? So upload file, and you can select the file, upload here, and you would be able to run that here also. This is the code part. Like if you want to add code, you can just click plus code. It will create a code cell. If you just want to add text, like markdown over here, like when you go to markdown and write some text, and it would convert that into a decent form. So you can do the same here, add text and say, hey, this is a tutorial of Google Colab, and it would show it in the form of text. If you don't want a cell, select the cell. You can see the cell is highlighted. Just click on this delete cell option, the bin button over here. It will delete it. If you want to edit a particular cell, you can click on this edit. If you want to add a comment, okay. One biggest advantage of Colab is we can share it with a lot of people without even sending it. For example, let's say I write an IPython notebook here. I need to download it, email it, add this as an attachment, send it to you. Then you open your email, you download the file, and then you upload the file into this area to see it. But when we use Colab, we can just share it. Let's say you give me your email ID, then I can just say, put your email ID over here and share it with you. Now, when you go to your Colab, Google Colab, you can see all the programs that are like shared with you, and then you can just start looking at it from here. So sharing becomes easy. And that's the reason this comment option is there. Let's say here, I select this comment option. I say, hey, at some person, let's say I'm going to select one person here and say, can you recheck this code? It is kind of throwing me some error, and put comment. It will notify this person, and also this comment, which block it was commented, that would be there. So this is called collaboration. When for learning, Google Colab is like a fantastic tool. So you can collaborate with multiple people. I'm not encouraging this, but just in case you take some assignment somewhere and you want to try, because when you are learning, the more you practice, the better for you, right? So you want to learn. So instead of you trying it on your own, let's say all of you form a team and you want to learn together, then you go create a collab and share it with the rest of your team members. As you are working, others can also access that notebook and see what you are doing, and maybe let's say on one of the code piece that you have written, they can comment saying, hey, this code is not working, or this code is not efficient. Can we do it in a different way? Can we write this way, right? So that way, if they comment, you would be able to see and rectify it. Once done, you can say delete this. Then that tag will be deleted. Look at the resources that you are using. It is connected to a computer behind the scenes, and that computer is actually provided to you by Google. So when you run this code, it's actually running this code on somewhere, a computer which is at a Google data center, and you are accessing it from a browser, right? And that's why execution would take a little more time over here. When you actually want to see the computer, like what it is giving you, you can just see view or manage resources. It has given you a disk space of 107 GB, and it has given you a RAM of 12 GB. This was the advantage that I was just speaking a little while ago. Why use Colab? Why not use something else, right? So if I have a very good computer, let's say I have a computer with 32 GB RAM, then I can pretty much use my computer, because the base version of it is giving me only a 12 GB RAM. And if this is not sufficient enough, you may be thinking, 12 GB is a good RAM. Why is that not sufficient enough, right? Welcome to the world of data science. 12 GB is like nothing for us. If you have CPU that has, like, let's say quad core CPU, it can run 8 threads. You might not have used 100% of your CPU in your lifetime, or if you are a gamer, you might have. In data science, when we run programs, it just fills up your CPU in a matter of split seconds. In no time, all your CPUs would be like clocking 100% usage, and your RAM usage would be going to 100%. And sometimes it throws error, hey, not enough RAM. Because when we handle a lot of data, all the data during the execution phase sits on the RAM. So that's why we need even better RAMs, right? These days, 16 GB RAMs are very common. So when we use our own computer rather than using Colab, this is the advantage we get. But not everybody might have such a powerful computer. So this is like a decent version of it. Sometimes what we need is a GPU. And if you don't have a GPU based laptop, that's where Google Colab is going to be a real boon for us. You can see here at the bottom, change runtime type. So just click on this and another window pops up. Right now, hardware accelerator says none. If you click on the drop down over there are two things. One is called GPU, another one is called TPU. You might not be aware of a TPU, so don't worry. When we go to the deep learning section, we will explain what TPUs are. GPU, which is called the graphical processing unit. So if you want you use GPU, then you can pick GPU and save. GPU class, by default, it is standard. If you think that is not enough, you can say purchase additional compute units. Let's say, for the sake of it, I click on the purchase additional components. If you go for Colab Pro, you get faster GPUs. If you go to Colab Pro Plus, which costs $58.99 per month, you get it gives you 100 compute units. This is like 100 compute machines that you can use per month. In Colab Pro Plus, you can get 500 compute units per month. So you can actually pick one of them, and you will get faster GPUs also as part of this package, right? But I'm not going to use them, so I would cancel that. Okay. So for any questions? Okay, good. Even Colab.
Are we going to use both Colab and Jupyter, or whatever is required when?
It's a simple choice. If you have a good PC, right away, go ahead and start using your own PC, which is Jupyter Notebook.
Okay, even for the course, you're saying it's our choice.
Even for the entire course, you can use Colab.
Okay, thank you.
Right. But if you have, like, let's say, a 16 GB RAM, good CPU, and even a marginal GPU given in the computer, why waste it, right? Let's use that.
So this Colab has whatever packages that Anaconda has, or do we probably have to download? I mean,
Not all of them, but most of the packages that are available in Anaconda are also available in Colab already. Okay. With few exceptions. Some of them might not be. And even Colab was an environment created keeping data scientists in mind, keeping machine learning in the context. So that's why for all machine learning packages, you more or less see them. Okay, now what is this package? What kind of packages do I actually need? So when we go to this python.org, you have a tab called PyPy, which stands for Python Package Index. And in this, you can find all the packages. For example, let's say I want a package with the name pandas. So you might be thinking like, how do I know the package names? And don't worry, we will get used to it. So pandas is like a very popular package. Right now, pandas version 1.5.3, and we got pandas 2, but that's not stable, so people don't use it. So this is the latest version of pandas 3. So let's say pandas 1.5.3, and we want to use it. Okay. That's why I wrote some of the most important packages, right? NumPy, Pandas, Matplotlib, Seaborn, Sklan. These are some of the common packages that we use. Now, to check if a package is there or not, we can simply write something called as import pandas. If this package is already installed on your PC, when you run this step, it won't throw any error. It just runs. Okay. Now let's say I create something called import cookie cutter. These are some crazy names, but don't worry. Now you can clearly see there is an error. No module named cookie cutter. So it threw an error, right? Now we have to install this module. That means we have to install this package. There are many ways to install a package. One, we can go to PowerShell, launch a PowerShell. So see here, this is like command file in Windows, terminal in Linux or other things, right? Here we can install something like using this statement, pip install cookie cutter, assuming that there is a package name called cookie cutter. It will install it, otherwise it will throw error. See here, it picked the collecting cookie cutter and it installed, and it completed, successfully installed, right? And it also installed all the dependency packages as well, right? So now we have installed cookie cutter on our Python. Let's go and try to test it. Do we have cookie cutter? Now see, the moment I install that by going to the command PowerShell, it's no more throwing error. It clearly says, yeah, import cookie cutter, you asked for it, it's already there. Okay. Generally, sometimes when we download, when we import pandas as PD. So this is like a alias, a shortcut. Why? If each package is nothing but a whole bunch of functions written in it. Pandas will have like thousands of functions written into it. So if I want to use a particular function, I can say pd dot, let's say the function name, and I can use it this way. So every time I have to call a function which is there in pandas, I don't have to type pandas dot. So if we give a shorter alias like pd dot function, it would make things easier. So this is another way of downloading it. Okay, so this is one way. We can install from here also. We don't have to really go to the PowerShell to install a package. Let's say pip install NumPy. NumPy is already there, but I'm just going to install it to show what happens, right? So it did not throw an error. It simply said, hey, requirement already satisfied. NumPy is already installed for you. Don't worry about it, right? So if it is not there, then it would have installed. So these are like when you put this exclamatory symbol before this, that is command line prompts. So whatever you run in the command line prompts, that you can run from the shell also from here. So this is another way of installing it. Now let's go to Colab and try to use the same. Import pandas as PD. Let's see if it exists. I'm running this shell, it ran successfully, no problem. So that means pandas is already installed. Import numpy as np. Let's see if it is already installed for us. Oh, it's installed. Let's see if cookie cutter is also installed. Now it threw an error. Module not found error. No module named cookie cutter. Oh, looks like nobody installed cookie cutter in Google Colab. Now let's see if I can do the same over here. Pip install cookie cutter. It works like magic, isn't it? Now, what we did on the same Anaconda Jupyter Lab, we did it over here. And now when you run this import cookie cutter, no problem. Cookie cutter is available for you to use. So because we did install using the magic command. So there's like a magic command. We just use the magic command here and then install it. Right now we can use the functions that are available as part of cookie cutter. Okay, so this is how we are going to use it. Just to summarize, if you think you have good computer and we can make use of it, good RAM, CPU, if at all a GPU, best choice is go and set up this Anaconda, download this file, install it, everything will be there. When you go to here, just pick Jupyter Lab, and we will work with it. That's it. If you think your PC is not so powerful, going to Google Colab will make it even better. And it's also easy to collaborate. Like if you want to share, if you want to see, when we go to some of the tougher modules, we will be giving you assignments. And when you do that assignment, it's easy when you do it on Colab, because you can simply, after completing your assignment, you can click the share button and you can add one of us to go ahead and have a look at your code and kind of give you where, if you have made mistakes, some feedback, etc. So that collaboration becomes easy using this Colab. That's why the name Colab, right? Colab stands for collaboration. But for practice where you need better CPU power, if at all you have it on your computer, better to stay with the Jupyter Lab, right? It makes things easier. You are writing a code and you are stuck, there are like repeated errors. You can drop an email to one of the helping faculty and tag them over here and say, hey, I'm getting repeated error. Can you see what mistake I'm doing? They will be able to open, and once you share this notebook with them, they can go and see and help you resolving that, right? So collaboration part becomes easy when you do this. That's the only difference. Okay, I will stop here.